Right, so without further ado, I will begin our lecture today. Still number is being low. Morning class is that, but we already started for chapter 7, sulfur-based industries, and we have looked through the introduction of sulfur and the application or the uses of sulfur in various industries. Right. So today we are going to look at the sulfur cycle. So as I said, sulfur cycle is essential because this is basically how we can produce the sulfur-based chemicals naturally. The sulfur is actually produced from the acid rain. As you know, probably the source of sulfur coming from ocean, coming from volcanic activities. All these are actually producing sulfur dioxide, and then when it goes or when it evaporates, it becomes sulfur trioxide due to the oxidation process, and then after that the sulfur trioxide can easily react with moisture or water from the clouds to produce sulfuric acid, and from there you can have different kinds of uh, sulfur-based products. So for the sulfur cycle, it describes the route that sulfur atoms take through the environment. It's often called sedimentary cycle. Much of the sulfur is tied up in the underground rocks and primarily released through geological activity. So as I said earlier, that the source of sulfur could come from sulfide ores. Okay? So any geological activities due to eruption of volcanoes, due to mining and whatnot, all these actually will produce or release sulfur. It is then used by the plant and subsequently animals. Sulfur is mostly taken by plant as sulfate and used for amino acids. Okay? And it has a gaseous phase, which in this case, it exists as a non-metal, so it is faster than those cycles without a gaseous phase. Right, so much of the Earth's sulfur is stored underground in rocks and minerals, including sulfate salts. It is normally buried in the ground, so not only from sulfide, it can also have sulfur from sulfate minerals. Please recall back what you have learned in chapter 4 regarding on the minerals, and then you can see from there that apart from these minerals, the source of sulfur can come from volcanoes and heat springs and hot springs. Okay, from the industries also that release sulfur dioxide, especially in metallurgy industries, when you perform roasting process, it will release actually sulfur dioxide. So all this actually will be converted into sulfuric acid, and then the reaction of sulfuric acid with ammonia that is available on the ground, then it will produce like ammonium sulfate, and this actually will be consumed by animals and also plant. And how does sulfur enters the atmosphere? So sulfur can become from various sources. It is also coming from hydrogen sulfide. So hydrogen sulfide is poisonous gas and corrosive gas that you can actually found in oil and gas industries. And I guess due to this, because it contains sulfide, then most of this gas actually have certain features, like it is colorless, poisonous, it has a rotten smell, and it is normally released during the volcanic eruption, decomposition of anaerobic process, and whatnot. Okay. Sulfur also enters the atmosphere as a sulfur dioxide. This is actually from industrial, activities, or from the eruption of volcanoes. And sulfur also enters the atmosphere as a sulfate source. As I said earlier, some of this mineral actually contains in ocean, in ground, underground, or what. Then this actually will produce sulfate. So probably you might experience when you sit or when you stay near to the seaside and you will feel the breeze. There's a smell. Near to the sea. That is actually coming from sulfate. The minerals that leach out and goes into the ocean when it is been when the tide is actually hit the rocks or what, then you, spray, sea spray, then you smell like ocean smell. So this is actually coming mostly from sulfate minerals. Certain marine algae produce a large amount of volatile dimethyl sulfide, DMS. So this is also part of the source for sulfur, okay? Because marine algae, it actually use and produce these chemicals during their aerobic and anaerobic process. It serves as a condensation nuclei for water droplets and can affect the cloud cover and climate. Sulfur dioxide in atmosphere, it reacts with oxygen to produce sulfur trioxide. Okay. So this is actually a further oxidation process. It reacts with water vapor to make sulfuric acid, a weak sulfuric acid. So it's not like a very strong acid that is prepared during the process of sulfur trioxide with water. And it is actually carried out to earth in rainfall. So this is actually what we call it as acid rains. And sometimes if the concentration of sulfur dioxide or sulfur trioxide is quite high, then the concentration of sulfuric acid produced will be high as well. And this actually will be harmful to the trees and also aquatic life. The human effect on the sulfur cycle, 1/3 of all sulfur release is due to the human activity. So part of the activity actually you can see it's from electricity, from building and industries, transportation, and etc. So they add sulfur dioxide to atmosphere by burning coal and oil that produce sulfuric acid, refining of sulfur containing petroleum, mining and converting sulfur containing metallic ores into free metal. This is actually what I explained to you earlier regarding on roasting process. In extractive metallurgy, you learn about pyrometallurgy. Pyrometallurgy, part of it is actually on roasting, where it converts sulfide or halide ores into free metals. The sulfur cycle is the collection of processes by which sulfur moves to and from minerals that includes waterways and living system. The positive effect is that it used in many applications or many industries, such as in chemicals, medicine, plastic, papers, and etc. And it serves as an important element in plant for the formation of amino acids, protein, oil, chlorophyll, and promotes nodulation in legumes and activates certain vitamins and also enzymes. But it also has a negative effect, of course. The major one is actually it produces acid rain. It increases the acidity of the soil. Okay, so that is why if you actually have some knowledge on farming, you will notice sometimes people put like apa tu chap or kapur lah kita cakap in Malay. So if you want to like plant pineapple nak tanam nenas ke, or you want to plant oil palm ke, or other things, what you need to do is after you have like clear the ground, okay, dah apa tu dah ratakan tanah and whatnot, then part of the important thing is actually you need to neutralize the soil. Then you'll apply some amount of chalk or kapur lah. Kita letakkan kapur pada tanah with the objective to neutralize the soil. Because if the soil is slightly acidic, then this could be harmful for your seed or for your plant. You try to put your seeds, and then what happens is if it is too acidic, then the seeds cannot really absorb water and whatnot, and makes it cannot grow. And it also slows down the growth of a plant. Of course, when the soil becomes too much acidic, then water absorption to roots cannot be done entirely. It also lowering down the pH of the water. When you have like too much acidity in the soil, it will be leached out. It goes to the river, to the streams, and then increase the pH of the, decrease the pH of the water. And it also increase the concentration of aluminium in surface water and eliminate small insects and also fishes. Right. So now we are going to look at how sulfur is being recovered. Okay. So sulfur can be recovered, especially from three basic ways. The first one is actually a mining process through the use of well drilled to sulfur deposits and work with the Frasch method. So this is actually part of the important methods that you need to remember, how you can recover sulfur. It's known as a Frasch method. So remember this term. It can also be extracted from oil and gas stream at processing plant, and sulfur can also be recovered from the scrap surface of the earth, or normally dug out from open pits mining. Right. So for sulfur mining, the method that is very much related to you is a Frasch method, developed by German chemist Hermann Frasch. It must be used to recover these deposits. So this process consists of circulating superheated hot water and steam through the well, melting the sulfur. So the idea is basically you dig a well, and then after that you pump it with hot water. So this super hot water will actually melt or release or recover the sulfur that contains in the soil or in the minerals. Then the compressed air is forced to the well and pushing the liquid sulfur up to the surface. So this allows the recovery of the sulfur at the surface where it is melted, cooled, and also solidified. So what happened after you have like pump in the hot water solution? It will actually dissolve the sulfur, and then you will recover in the end liquid sulfur. So this liquid sulfur will be settled, it will be cooled down, and also it will be solidified.